I went live with something blocking the screen. Brilliant. Morning, everyone. Hey, starting in a couple of minutes. There's going to be this lesson on converting units. Woohoo! Well done for getting up early. I'm impressed. I'm very impressed. Okay. Let me just fix my webcam now. I've just broken. This is great, Telly. Tell everyone. There we go. I think that's working. Okay, so there's a question here to start with, to start thinking about. What is? Oh man, I didn't correct my spelling mistake. Oh, why didn't I do that? Ruth, come on, you knew about this. There we go. What is wrong with this sentence? I would like a meter of juice, please. What is wrong with that sentence? I would like a meter of juice, please. Whilst having a think about that, you could also, if you've got Facebook, head over to Facebook to say hi. There's a little post there if you want to say hi to me, and I'll say hi back. And you can also make sure you've got these things: a tin of beans or tomatoes or something similar, a tape measure, a calculator, a bag of flour or sugar, and something that you can weigh that flour or sugar with, like some weighing scales. I mean, not like just weigh. That was an awful joke. But I love it. Okay. I always light an incense stick at the start of my live lessons. For those that are interested, we're working with some lovely nag champa today. Okay, have I got everything? Does this pen work? Yes, I think it does. Okay. I'm nearly there. I'm just checking out whiteboard pens, which ones work and which ones don't. There we go. Good morning, that's Bob. It is early for Friday, hey? Whew, these dark mornings. What was I thinking? 9 o'clock. Good morning. I am Ruth. This is Joyful Maths with Ruth. You are here for my GCSE maths lessons, which are focusing on Foundation GCSE, Functional Skills 1, Functional Skills 2, suitable for all exam boards, apart from Cambridge GCSE. That's the only one that it's not going to work for. Anything else, we're good. We're good on those. So I asked you about this question. What is wrong with this sentence? I would like a meter of juice, please. So it's not a commenting lesson, this one. This one's like slightly different. I like to have the option to comment on Facebook on a Tuesday and the option for those that don't like all the comments on a Friday. But loads of people on Tuesday were commenting like, you can't have a meter of juice, Ruth. Well, you possibly could. Like, I could have this glass a meter tall, couldn't I? But like, it'd be very hard to drink out of. You don't measure a liquid in meters, do you? No, of course not. We measure liquids in other ways. That's called a capacity. So we would measure that in something like maybe milliliters, liters. Lots of people said that. Now, a little note on spelling whilst I'm here, because did that wind me up with this lesson. My spelling is dire. I really not a strength of mine. I just can't remember how to spell things at all for some reason. But I was convinced, like, we spell meters R-E at the end, and liters R-E at the end. And then everything I put it on, because I planned these on PowerPoint, kept flagging up spelling mistakes. So I changed everything to ER as it suggested. And then I was like, no, I'm going to Google that. And now in the UK, we spell it RE. It's from the French spelling of these words. So that's the French influence, I think, from the Normans. Anyway, we're not in history right now. So I think it's that sort of it. That's where it came from. But in America, you've got the option to do ER. So yeah, there we go. PowerPoints for American spelling. We're going to start off then deciding which of these work for different measurements. I'll show you because it's a bit easier than me explaining. I haven't got my vocabulary. Sometimes a bit rubbish. Here we go. So we've got 3 different things we might want to measure: weight, distance, capacity. And I've got lots of different types of measurement up here. And we want to put them into the right category, what we would use them to measure. So if you think milliliters would measure distance, you would put it underneath distance. I'm going to give you a clue. It doesn't. Milliliters doesn't measure distance. So put it somewhere else. Yeah, so we're looking at weight. So how much something weighs, distance or length, and capacity is like how much volume or like how much fits inside something. Okay, so I'm going to give you a second to do that. If you've got the workbook, you could do this in the workbook, but you don't need it. You can do it like on a piece of paper. You can do it on a whiteboard. I love whiteboards because you can rub them off, or you can just think about it. You can just go through each one and think about where you would put each of them. So I'm going to be quiet, so you've got some thinking time. Luckily for you, I've got coffee, so I've got the ability to be quiet for a little bit today. I'm not going to give you loads of time on this. Apologies, because you probably need longer to write it down. But yeah, I'm just giving sort of thinking time, maybe. Thinking time on this one. Can you hear me playing with the water bottle? It's got chilly enough for me to need a water bottle, hot water bottle. Can you believe that? But because I'm fidgety, I can't resist playing with it. Okay, right. So, how are we finding that? Did you notice anything about some of those? You might have noticed that some of those are like measure. You probably recognize most of them, but some of them are like measurements that you're used to using a lot, and some of them you're less used to using. And we're going to talk about that a little bit in a second. Okay, I've got answers. I'll show you the answers on the screen for those that were using the workbook so you can actually see. But yeah, we've got under weight. The grams, tons, and kilograms are all measurements of weight. Centimeters, millimeters, and kilometers are all measurements of distance, and liters and milliliters are measurements of capacity. But there are other ones. We're not limited to just those ones. That was just a little sample. So we're going to talk about different types of measurement: metric and imperial. For some reason, my brain went to metric being about robots and the future because they're like the more modern measurements. And imperial, I've put a little granny knitting a little scarf, I think. I don't know why scarf had to be said like that, but it did. It was important. So imperial are the more old-fashioned traditional measurements, okay? And we're going to have a little look at separating those out. Now, it's a little bit odd because nowadays there tends to be metric units used more frequently. So things like grams, kilograms, meters, you might notice they're used more frequently. But if you're in the UK, all our speed signs are in miles per hour, which is an imperial unit. So it's a little bit odd. We're not consistent with it. You might find that when you're talking to an older person about recipes, instead of using grams, they might use things like ounces and things like that. So it can get a little bit confusing, which is why we need to be able to convert between them. This is actually a really helpful real life skill. This is one of the things on like GCSE that's like super, super real life and super, super helpful all the time. So the first thing we're going to do is play a little game called Robot versus Granny, obviously. How else would you do this? Where I'm going to tell you something I want you to measure, and you're going to suggest a metric unit and an imperial unit I could do that in. I'll show you because it makes more sense when I show you. She says, hopefully. Okay. So examples of metric units: meters, grams, and liters. And then you'll notice there's other words where we put a little bit in front of them. Examples of imperial units are like miles, inches, pounds, ounces, pints, gallons. So they're less interlinked language-wise. These ones have got a really strong link with language because you put like killi, centi, what else? Kilometer, centimeter, millimeter, and you can put those in front of these and it makes sense for all of them. But for these, we actually change the word totally. So if we think about like pounds and ounces, they're not linked in terms of language in the same way. Okay, let's have a look at these then. So robot versus granny. I want to weigh a bag of potatoes. How might the robot do it? The robot might do it in kilograms. So that is my metric version, my metric weight. The granny might do it in pounds. So that's my imperial weight measurement that I would likely use for a bag of potatoes. Quite a fairly heavy weight, but I could probably pick it up. Okay, let's give this a go then. So this is for you. Distance from Edinburgh to London. Distance from Edinburgh to London. So how would you measure it in metric and imperial? What unit of measurement would you use, do you reckon? Okay, next one. So length of a bus. So I want a metric unit that you would use to measure a bus in and an imperial unit you would use to measure a bus in. What would you use? What measurement would you use to measure a bus? Okay, are we ready for the next one? Okay, next one. Diameter of a tin of beans or tomatoes or anything. If you're going across, the diameter is all the way across the circle bit at the top. What metric measurement would you use? What imperial measurement would you use? And I can't remember if I've got one more. I think there might be one more. Oh, no, there isn't. Okay, let's have a look at these then. Let's have a look at these. So distance from Edinburgh to London, metric, a good unit of a measurement would be kilometres. If we did like centimetres, it would be, you would need a heck of a lot of them to go that distance. So we need quite a big unit of measurement there. Miles would be the imperial equivalent to that. They're not equal to each other, though. A kilometre is shorter than a mile, so you would need more kilometres than you would miles. If you've been to Europe, you might notice that their speed signs are all in kilometres per hour. So actually, they tend to be higher numbers because you need more kilometres to be going the same speed. Okay, for the length of a bus, the metric one would likely be meters. Meters would be a really good one to measure it. And again, you could go for something like centimeters, but you would need a lot of them. It wouldn't be wrong to use centimeters. You'd just use a lot more. Feet is a really good one for the length of a bus in imperial as well. Again, you might use something else. You could use something like yards maybe, or inches. You would just need quite a lot of inches. I can't remember how long a yard is. I think maybe a yard would be fine as well. I think a yard is maybe 3 feet. For the diameter across a tin of beans, you might use centimeters or millimeters. I mean, you would need more millimeters because they're smaller, but either of those would be quite reasonable. For in imperial, you would use inches. So inches would be a good one for the diameter across a tin of beans. Okay, so where did these imperial and metric come from? Let's have a little look at that. Now, I think I'm annoyed with myself because I thought I knew something. And then last lesson, something happened that made me go, I'm not sure I've got that right. So I was absolutely convinced. Actually, let's start from the top. Imperial measurements often started off as parts of the body that people could actually use when they were bargaining or bartering with each other. So like a foot was actually the length of the average length of a man's foot. So they would use their actual feet to measure them out. And various different things like that. Now, I was convinced an inch was the distance from your knuckle of your thumb to the end of your thumb. Okay, so I was like, oh, well, I've got quite small hands. I haven't got very big hands. So I was like, oh, mine will be less than an inch. But then I did something with it during Tuesday's lesson, and I realized, oh, no, that's not less than an inch. In fact, if I measure it, an inch should be about 2.5 centimeters. Mine is just over an inch. It's coming up. It's like 1.25 inches. So I was like, what's going on there? So actually, this bit's wrong. An inch on a man was it was the width of his thumb, not that section. So I said that wrong on Tuesday, unfortunately. The width was at the width of the thumb, so it was going from side to side. That was an inch, and mine definitely is smaller than an inch. So I was right about that. So let's have a little go. Let's have a little experiment with that. If you've got a tin with you, these tend to be roughly a standard size, which is why I chose one. And I thought it'd be interesting for you at home to try measuring using your thumb how many inches the height of the tin is, and then we can like have a little comparison. And I'll tell you some of the answers we got before, and then we can actually measure it and see what happens and why we might have had to change how units were used. Okay, so I'm going to do this. I'm going to put my thumb on my tin and then mark where the edge of it is, and then I have to keep moving it down. Can you see that? I'll show you. Maybe is that going to roll? Keep it still. Stay still. Stay still. There we go. Okay. Let's have a little look. So if I'm going to put my thumb there, mark with my other finger. Oh, it came to there. So then I move my thumb down. So that's 2 inches, 3 inches, and keep going like that. Only I'm going to do it a little bit secretly so you can do it yourself and we can compare with each other. Okay. So let me just do it. This is brilliant, Tolly, I know. I need to concentrate though. I can't count silently. Why not? Okay, I've got my answer. I'll give you a second to get yours, and then we'll actually compare it to what it is. Okay, so what's it like? I mean, I can ask you what you got, and you can shout, and I can try and listen. Probably I won't hear you. I got 7 inches. My thumb, the width of my thumb, fitted on there 7 times. Now, my experience on Facebook was that my answer was wildly different to the answers of other people's, which is why we had to standardize units, why they stopped being measurements of people's bodies and became actual standard units. If we measure this with a tape measure in inches, you might notice here that inches, they are larger than centimeters. They're about 2.5 centimeters. So yeah, when we measure the actual tin, and in fact, I'll do that on the camera so you can see. And you can see if your thumb is roughly 1 inch or not. In fact, you could probably just measure it. Oh, it ends up being, oh my gosh, mine is way off. 5.5 inches. 5.5 inches. And you can see the width of my thumb, nowhere near 1 inch. Not even close. Yeah. So that makes sense, doesn't it? So we had to standardize it for that reason. The other one that I came across, which I thought was quite cool, and you might want to have a little go at. Apparently a pound was how much somebody could comfortably hold in one hand. And I was intrigued to your thoughts on this. So I asked you to bring some flour or some sugar and some way of weighing it. So I've got some weighing scales here. Some weighing scales. We'll have a little go at that. So I've got some flour. I wish I brought sugar because it just makes less mess, but I didn't have a pound of sugar. Do too much baking recently, obviously. So I'm gonna actually I'm gonna flip this down so you can actually see. Can you see on there? So I've had to make sure my measurements are in pounds and ounces. It's in pounds and ounces on there. Is it at 0? Yes, it's at 0. So we need to measure out. Goes up to 16 ounces. I had to Google that in the middle of the last lesson because I forgot that one too. So easy to forget these things if you don't use them all the time. So we need about 16 ounces, and then it'll go on to 1 pound. Here we go. Woohoo! Ah, slightly over. But that's close. Eh? Very, very close. Right, what do you reckon? Give that a go. Is that can you? I mean, I reckon I could tell someone, oh no, I could definitely hold a lot more than that in my hand and blag a lot more flour out of them. But also, I'm just not, massively comfortable. Like, it's quite heavy just holding one hand, actually, isn't it? What do you reckon? It's not brilliant. Not the best measurement of flap. I'm pretty convinced if I gave that to my husband, he'd say, I could definitely hold twice as much quite comfortably. Like that as well. He would not be impressed. and he would get a lot more flour than me. And I wouldn't be happy about that. So yeah, we definitely need to standardize units. So there's imperial and metric. I'm going to talk about the metric ones in particular. So imperial on your actual GCSE or your functional skills test, you do need to know the conversions between the metric ones. They're all related to 10, 100 and 1,000. The imperial ones, you get given them and you need to be able to understand the conversion between them. Okay. So standard units in metric. These are our standard units. They're not to be confused with standard index, but standard index form. Anyway, so we've got our standard unit for weight is a gram. Our standard unit for distance is a meter. This is all in metric. And our standard unit for capacity is a litre. And then we can use language to change this. And this language actually means something very specific. It's not random. A milli means 1,000th. That means I've divided it by 1,000. So if I have a milligram, it's 1,000th of a gram, i.e. I need 1,000 milligrams to make a gram. A meter, if I divide that into 1,000 equal parts, I get millimeters. So I need 1,000 of the millimeters to make a whole meter. And similarly with milliliters. So that milli means it's got a lot smaller, a lot smaller, 1,000 times smaller. Centi means 100th. You see cent quite a lot meaning 100. So, or sorry, 100th. So in America, a cent is 100th of a dollar. So yeah, cent relates to that in a lot of different ways. You don't tend to get centigrams, but you do get centimeters and centiliters. This one less common unless you like. The only place I can think of I regularly see it is on a bottle of wine, which hopefully none of you are seeing that regularly. And then the last one is kilo. Kilo is actually getting bigger. It's excuse me. A kilogram is 1,000 grams. A kilometer is 1,000 meters. So actually, we would need a very small amount of a kilogram to make 1 gram. We would need a very small amount of a kilogram to make a meter. You don't tend to get kiloliters for some reason. I don't know why, but you just don't. They don't tend to be in standard form. So probably because a liter is quite a lot of something already. Like having 1,000 of them is pretty huge. What I tend to notice is that people often know this. They know the facts. They know that like 10 millimeters are in a centimeter. They know there's 100 centimeters in a meter. They know there's 1,000 meters in a kilometer. Or if you don't know it, it's something you can look up and probably remember for a test short term in some way, shape or form. What I've noticed is that often people don't then think logically about their answer. So they use the fact that there's 100 centimeters in a meter and say something like, oh, well, if I had 200 meters, it would be 2 centimeters. Because they've used the 100, they've divided by 100, but they're not thought logically. Look, 2 centimeters is teeny tiny, and 200 meters, whoo, I nearly had flour everywhere, is absolutely huge. So we're going to do a bit of that. I'm going to ask you if these make sense. I'm going to give you 2 units, and I'm going to tell you they're equal to each other in measurement. So it might be the same length, the same weight, or something like that. I want you to think, does that make sense? Is that actually true? Okay, so the first one is this. 1,000 meters equals 1 kilometer. Does that make sense? Is that true? 1,000 meters equals 1 kilometer. Does that make sense? Next one. 3,000 kilograms equals 3 grams. Does that make sense? Do you think that would be true? 200 centilitres, this is the third one, equals 2 litres. Does that make sense? Do you think that would be true? And the next one, 4,000 litres equals 4 millilitres. Does that make sense? If you got that answer, would you be like, yeah, definitely, that makes a lot of sense. I'll stick with that. Next one, 20 centimetres equals 2 millimetres. Does that make sense? And the next one, 5,000 milligrams equals 5 grams. Does that make sense? Would you be happy with that as an answer? And that was the last one. I thought there was another one, but that's all of them. Okay, let's have a look at these together then. So the first one that I asked you was, is 1,000 meters the same as a kilometer? We saw in the first bit that, yeah, that's true. Kilo means 1,000 of something. So we need 1,000 meters to make 1 kilometer. So the smaller thing we need a lot more of. Okay, that can be a little bit confusing. We need a lot more of the smaller thing. So if we look here, we need a lot more of the meters to get just 1 kilometer. So that one does make sense. That is true. Here we've got 3,000 kilograms. Now kilograms are much bigger. They're worth a lot more than a gram. See, this one doesn't make sense. We should have more of the grams and less of the kilograms for that to be true. So it should be the other way around. 3 kilograms equals 3,000 grams. Okay, next one. 200 centiliters equals 2 liters. Well, liters is the bigger one in this case because centi means 100th, i.e. we need 100 of them to make a liter. So this one makes sense. I've got 200 more of the smaller thing than of the bigger thing. So that one does make sense. What about this one? 4,000 liters equals 4 milliliters. Well, in this one, milliliters is the smaller one and liters is the bigger one. So I need more of the milliliters. So this one doesn't make sense. It should be the other way around. 4,000 milliliters is the same as 4 liters. And this one, we didn't talk about this one, the link between centimeters and millimeters. There, you can do this on a tape measure. You could just look on a tape measure or a ruler, which I'll do in a second actually for you. 20 centimeters equals 2 millimeters. Again, millimeters, because this one's 1,000th and this one's 100th, this is the smaller unit. So we would need more of them to make the same length as the centimeters. So this should be the bigger number. We should have 20 here and 2 here. And the last one, 5,000 milligrams equals 5 grams. Milli means tiny, 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 tiny. So this is the much smaller measurement. So we would expect to need a lot more of them. So that one does make sense. In terms of centimeters and millimeters, if you're ever unsure, you're always allowed to have a ruler with you, and you can literally use your ruler to help you with it. So if we look at our ruler, the centimeters, you have to look for cm for centimeters. Inches are much bigger. And the millimeters are the tiny little dashes in between. So you can actually count them. There was 10 of those little dashes in between. Well, not in between. There's 10 of them if you count the bigger ones as well. So there's 10 spaces, I guess, which represent 10 millimeters in between. Okay. So that is the big bit with the metric. Just checking if your answer actually makes sense, not just relying on a calculation and numbers that you've memorized. Check if your answer goes back to making sense. The other thing we need to be able to do is convert between units. Now, this is really useful in lots of instances, such as money conversions as well, which you'll see a lot of on all these types of assessments. So things like converting between pounds and euros, things like that. But we can also convert between different imperial units as well as imperial and metric units. So we're going to focus on, I'm going to give you conversions between imperial and metric units here. I'll give you the conversion and then ask you to do some calculations with them. So I'll show you an example to start with. The conversions in the green, and then I'm going to ask you some questions about them, okay? So the conversion is, this is the conversion you've been given in green here. 1 foot is the same as 30 centimeters. So that is a fact that you know for sure. So using that fact, have a little think about how you would do these. You're absolutely fine to use a calculator for these. I'm not asking you to do, I'm not like trying to test if you can do the calculations in your head. It's just thinking about what you would do and what calculation you would use in order to work these out. So 2 feet is 2 lots of a foot. 3 feet is 3 lots of a foot. 7 feet and 32.1 feet. Have a little think about how you would do those, and then we'll go through those ones and see if you can use it for some other conversions. Okay, so these don't rush understanding at all. So don't worry if you've not done all of those. You can practice once you've got understanding, then you can practice for doing things in time conditions. But we'll have a little look at this now. Hopefully you've spotted that it's a very similar calculation every single time. There's 2 different options here. You might have spotted that to go from 1 to 30, we multiply by 30. So to go from feet to centimeters, we're multiplying by 30. So you could take each of these numbers that you've been given and multiply them by 30. 2 times 30, 3 times 30, 32.1 times 30, and there was 7 times 30 in there as well. Another option is to look at the link going down this way and say, right, I've taken 1 and I've times it by 2 to get to 2 feet. So I'm going to take 30 and times it by 2 to get the number of centimeters. It's essentially the same calculation, just it's this understanding that multiplication can be done in any order at all is absolutely fine. But understanding different methods and trying different ways of doing things is really, really useful for you, especially when you're doing an assessment, because you might not recall an exact method, but having a deep understanding of where it's coming from and what you're doing with it is really, really helpful. So here we want to do 30 times 2, which gives us 60 centimeters. For the next one, 3 times 30, which gives us 90 centimeters. There was the 7 one as well, which gave us 210 centimeters. And the last one we would do 32.1 times 30, which I just did on my calculator, which gives us 963 centimeters. 963 centimeters. Okay, so we're going to have a look at this. So what happens if I want to go the other way? What happens if I want to ask this? What if I want to go from centimeters to feet now? Okay, so we've got the same conversion. I've left the conversion up here. 1 foot equals 30 centimeters. This time I want to go from centimeters back to feet. So I want to know how long each of these is in feet, please. what would you do to do those calculations? So if we're multiplying to go from feet to centimeters, if we want to go the other way, it makes sense to do the inverse. So the opposite. The inverse is the mathematical word for it. The inverse to multiplying by 30 is to divide by 30. So if we're going from centimeters to feet, we want to divide by 30. So for each of these ones, I want to do like 90 divided by 30, which gives me 3 feet, which we know from our previous one. Then I do 3,000 divided by 30, which leaves me with 30 feet. 3 meters, this one's a little more complicated because I'd want it in centimeters first. So I would convert that into the centimeters, which is what's in here. So I know that that is 300 centimeters before dividing by 30. So that's going to give me 10 feet. And then the last one gives you like horrible decimal answer. Well, it's not horrible. Horrible's the wrong word. A very long recurring decimal answer. 144.033333 and so on like that. 144.0333. And that keeps going on forever and ever and ever. Okay, so we've got some of those. I'll show you the answers on here too for anybody that likes to check them. So we've got that. If we know how to go one direction, we know that going the other direction, we're going to use the inverse operation. So the opposite operation there. Okay, converting units. Would you rather? We're going to have a little game of would you rather here. So here we're going to choose the longest one. Would you rather? We're going to choose which one you would prefer by choosing the longest one. So I'm going to give you a conversion like that. It won't necessarily be in green. I think the first one's in blue. And I'm going to give you 2 different measurements. One's going to be imperial, one's going to be metric. And I want you to choose the one you would rather. Which one's going to give you more? Okay, let's start. So this one's the first one. So 1 mile equals 1.6 kilometers. 1 mile equals 1.6 kilometers. Would you rather 2 miles or 3 kilometers? Would you rather 2 miles or 3 kilometers? Okay, next one. So this is question 2. Same conversion. Would you rather 10 miles or 15 kilometers? Would you rather 10 miles or 15 kilometers? Oh, sorry, guys. Don't know what happened there. Next one. Would you rather, so we've changed the conversion this time. We've got 1 pound equals 450 grams. Would you rather have 5 pounds of, say, chocolate? Let's go chocolate. Would you rather have 5 pounds of chocolate or 200 grams of chocolate? The same chocolate, I should add. Just got to open a window. My incense sticks made it a little bit smoky. Okay, next one. Same conversion. Would you rather have 8 pounds of let me think of something else. What else would you want 8 pounds of? I can't think. I'm gonna stick with chocolate. 8 pounds of chocolate and 4 kilograms of chocolate. Why can't I think of anything better than chocolate? Okay, I'm going to change the conversion now. So we're going to gallons to litres. 1 gallon equals 4.5 litres. Would you rather have 2 gallons or 10 litres? 2 gallons or 10 litres. Now, my head goes to kombucha with this one because I am making some epic kombucha at the moment. My kids love it. But you go for a drink you like. Maybe a nice tea. Maybe a nice fruity tea. And using the same conversion, would you rather have half a gallon or 200 millilitres of your favourite drink? Milkshake. Could be milkshake. Milkshake's good if it's made properly. Okay, I believe that is the end of Would You Rather. So should we go through some of those? Let's have a little look. Now, I want to emphasize, you may have done different calculations to me, but come to the same conclusion, and that is okay. There's not just like one set way to do these. I'll show you on a couple of them, but not all of them, because I think I'll bore you, Richard. But like, for example, the first one, we know that 1 mile is equal to 1.6 kilometers. So then when I asked you which you would prefer, 2 miles or 3 kilometers, I converted 2 miles into kilometers. So I did double the 1.6. So I did 1.6 times 2, and that gave me 3.2 kilometers. And I could compare that to the 3 kilometers that I asked in the question and say that gave me more. But there was also the option to take the kilometers and change that into miles. So you were given 3 kilometers. And if you want to turn that into miles, you would divide that. So I probably ought to put that on the other side, actually, to show you a division. So we could take the 3 kilometers and we could have divided that by 1.6. Because as we saw before, if we want to go from 1 to 1.6, we'd multiply by 1.6. So if we want to go the other way, we'd do the inverse. We would divide by 1.6. So we're doing the inverse operation. If I do that, 3 divided by 1.6, I'll show you on my calculator. It's going to give me like a fraction answer, but then I want to turn that into a decimal so I can compare them. So I do 3 divided by 1.6, press my equals button. It gives me a fraction. So for my calculator, I use this S to D button, which gives me a decimal number. But if you've got a different type of calculator, just check in how you do that. If you don't have this button, it might be that you have to press shift and change the format. And that gives me 1.875, which is less than 2 miles. So I could have done it that way as well. So there's not like a standard, like you have to do it this way sort of answer. So for each one, I'll give like one way of doing it, but just bear in mind you could have done it another way, and that's fine too. So the second one, it was 10 miles and 15 kilometers. So I did 10 multiplied by the 1.6, and that gave me 16 kilometers, which is more than 15 miles. So I'd have chosen the 10 miles in that one. I'd have chosen 10 miles. Then we went on to pounds and grams. So I know that 1 pound is worth 450 grams. So I could take that 5 pounds and turn that into grams by timesing it by 450. Again, I just popped that into my calculator. I can't remember the answer now. I think it was 2,225. Let me just check. 5 times 4, 50. Yeah, 2,225. 2,225. No, 2,250. I apologize. 2,250 grams. That is more than the 2,000 grams I had. So I'd have chosen the £5 in that one. On the next one, I've got £8 and 4 kilograms to compare. So again, I could use the same idea. I could do 8 times 450 to compare those two. When I do 8 times 450, I get, what do I get? 3,600, which is less than my 4 kilograms. So I'd have chosen the 4 kilograms in that case. Gallons to litres. Let's have a look at that. So 1 gallon was the same as 4.5 litres. 2 gallons will be double that. I'll put 2G. Will be double that. That gives me 9 litres, which is less than 10 litres. So I'd have chosen the 10 litres in that one. And then the next one I asked to compare half a gallon and 2,000 millilitres. Well, if 1 gallon equals 4.5 litres, half a gallon is going to be half of that, which is going to be 2.25 litres. This time I had it in millilitres. Millilitres, they are 1,000 times smaller, so I need 1,000 of these. So if I want to convert that into millilitres, I would have to multiply that by 1,000, which gives me 2,250 millilitres, which is more than the 2,000 millilitres I had on the other side. So I would choose the half a gallon, which sounds smaller, doesn't it? Because we're saying half of it, but gallons are just a really massive measurement. That's a huge amount of liquid. The last thing on converting, we're not going to do some questions on this. I just want to introduce you to it. If you're doing functional skills 1, you don't need this. But for functional skills 2, GCSE and GCSE on foundation, you definitely need to be able to use graphs convert units as well. So I just give you a little demonstration of that. And then on the workbooks, I've given you places where you can find places to do practice on this. You'll need to print them out so that you can draw on them to help with that. All right. So let's have a little look here. You can use this graph to convert between meters and feet. It asks, what is 15 feet in meters? So because I'm converted, I know the 15 feet. I need to look at my axes and find the one that says feet. Feet is along the bottom. This is the x-axis here. And I find the number 15. Now I'm going to draw a line vertically up, following that line perfectly up to the conversion line that's drawn on the graph. And then I'm going to draw a line horizontally across, keeping it in line. It might not hit exactly on one of these lines, so I have to keep it parallel to them, going across. And then I'm going to read off this measurement here as best I can. I'm looking at these units here. It goes from 4 to 6, so it's going up in 2s. I know halfway between 4 and 6 is 5 here. That is just over halfway between 4 and 5. So maybe about 4.6 meters, roughly that, about 4.6 meters. If I wanted to do it the other way, if I wanted to know what is 4 meters in feet, I would have to go to the meters axis. That's going up and down on this y-axis here. So I'm finding 4 meters, and I'm going to draw my line horizontally across to the conversion line and then come down to read the feet. So in this case, I'm going across to the line, come down, and again, I'm looking at this scale really carefully. This time it's going up in 5s. So I can work out what each of these tiny little squares is. If 10 little squares is worth 5, each little square is worth half. So I can go 10 and a half, 11, 11 and a half, 12, 12 and a half, 13. So it's about 13 feet. Okay, thank you so much for those people joining live. I'm going to say hi to those people that managed to go over to Facebook to say hi in a minute. Before I do that, I just need to explain how these free lessons end up giving me money towards my wage. That happens by people that sign up for £5 or £6 a month, and that goes towards all the time I put into planning these lessons, planning the workbooks, putting them out to you guys. And I send those people a thank you in the post to say thank you for making this something that is viable to do. At the moment, you are getting this Fractivities booklet in the post, which is all about fractals that I love, an area of maths you never see in schools, how to explore it in hands-on ways and through puzzles and problems. In there, it comes with some beautiful origami paper and some stickers I designed. Very soon, I am so close to getting out my next one, which is my weather activity book, which is going to come out before the end of October. I'm absolutely adamant it's going to come out before the end of October to people that are supporting. So if you sign up today, you will get that one through the post, and then you will almost immediately get the weather one through too, which is pretty exciting. Okay, I'm going to say hi to people. I just need to find my phone because I just threw it before the lesson. I can't remember where. Oh, okay. It's in my pencil case. That's good. That's good. Right. Let me snooze that. Reminders. Who has reminders? There's so many of them. Okay. Say hi here. Here, this is the one. Good morning. Oh my gosh, you guys, you got up early. Well done. Well done, guys. Hi, Harmony. I'm so impressed that you got up to be here. Well done. And Scarlett. Hello, Scarlett. Good morning. Oh, and Jacob. Well done for getting up as well. Good morning. I'll do a quick refresh just in case anyone's commented it. Oh, man. The cough still lingers a little bit. Still lingers. Okay, I'll just do a quick check in case anyone else commented and make sure I've said hi to everyone. Okay, I think I've got everyone. And hi to everyone that doesn't have Facebook as well. You guys are also super, super important. Thank you for joining me. I'll be live again this time next week on YouTube, doing GCSE maths again. I will be live at 11:30 today with my Maths in Dinosaurs lesson, all about did dinosaurs really go extinct? And I will be live on Facebook on Tuesday. And you are more than welcome to any or all of those. Bye for now, guys.